Hi all, good morning, good afternoon, good evening. Now let's talk about the rolling update strategy. In my previous video, I have talked about the recreate deployment strategy in the Kubernetes cluster. Now let's start discussing about the both practical and theoretical session of the rolling update strategy in the Kubernetes application. As you can see in my slide here, my end users, okay, are accessing the application version v1 which is deployed in my Kubernetes cluster. In meanwhile, my developers has finished their application version v2 and it is ready for deploying and accessible for the end users. So now let's see how theoretically it happens is. Now I have deployed the version v2 in the same Kubernetes cluster and end users have started accessing the application. Okay, so if you would have seen here, okay, earlier there are three pods here, okay, and the fourth pod is the version v2 which is not accessible for end users but it is not deployed yet still. So now I'm going to deploy it. So after deployed, okay, so there would be one pod out of these three pods of version v1 would be deleted, okay, and then the other third pod would be used as version v2. So similarly you see here the other second pod has been created in v2 before the second pod has been terminated in version v1 in the same cluster, and again the version 3 version v2 third pod has also been created version as version v2 in the same Kubernetes cluster, and in the version v1 Kubernetes cluster version v1 pods of the cluster has been deleted or terminated. By this, all the pods which was running in version v1 has been upgraded to version v2 without a downtime. So by this, some of the companies or enterprise would be following this rolling update strategy such a way that there is no downtime and gradually there will be each and every pods getting terminated and created in the new version from older version to the new version. So now let's get into the technical session to see how this has been deployed in my Kubernetes cluster. Let me switch to my gcloud session. Okay. So let me open my deployment file. I created a new deployment file named as v8 deployment of rolling update.yaml. So let's now walk one by one here. As I told earlier, this is the deployment kind statements. You can see the name of the deployment. You can see the replica set as 3, and you can see the strategy type is rolling update. And there are some keywords I have put up here saying that rolling update max unavailable 0, which means there cannot be there cannot be a scenario in which all my pods are terminated at the same time. So which means either way I will not have a zero downtime. Okay, so there is no downtime at all. At least there should be one pod serving my traffic. Max surge is one. If you would have seen here, there are three replicas. If I am going to give it as a max surge one, during my deployment of new version, there will be another new pod created as fourth pod. So the fourth pod would be started serving a traffic of new version v2. So the other pod, the third pod, would be of version v1 started getting terminated, which means the traffic which was flowing to the one pod out of the three pod would be diverted or routed to the new version pod. So which means there is no downtime. At least one pod is available at a time. So this all same how it was like earlier one. App name, container name. Okay, so here if you see the gcr path, the container registry path, okay, gcr.io slash ultimate hyphen square hyphen 254202 hello hyphen la colon v2. So let me change this as v1 and deploy the v1 version first, and exposing container as port 80. So the same for services, specifying the kind of service and name as deployment strategy example, and the label name also same. And I'm giving the spec of the service ports saying that port is 80, target port is 80. The protocol what I'm going to use here is TCP, and my selector app name is load deployment strategy example, and the type is load balancer, which will be my Google's provided load balancer. So let me save this file to run it. Okay, so as you can see here, let me give you get all to see any pods or deployments is running. So you can see that there was no deployments, there was no pods. It's having only a default Kubernetes cluster, which is well fine enough. Now let me go ahead and deploy my Kubernetes cluster. Kubectl apply hyphen f sorry hyphen f deployment hyphen rolling update.yaml. So as you seen in last session of the recreate deployment strategy, it is creating a new deployment name by deployment strategy example and as a service deployment strategy example. So now let give command cube kettle get all, that you could see that there are three pods running and three pods are running shift last 18 seconds, and the service name is, you can see the deployment strategy example is the service name, and type load balancer, which is pending with registering the IP with Google. So it will take it will take a minute at least. And the deployment name with three replica sets, and these are the replica sets, and three is a desired state and current is 3, and all three are ready for accessing it. So now let's tail for the services to get registered. Oh, fine. So I got my services. So let me access my service. Okay. My port is 80. You can see there's greetings from Rajesh Kubernetes Academy in GKE. So which means my version V1 has been deployed. Now let me go and deploy my version V2. If you see my container registry, now my version V2 is ready. I'm going to deploy this version V2. In the meanwhile, version V1 also should be available. So gradually version V2 ports would be replaced by, the version V1 ports would be replaced by my version V2 ports. So let's see practically how it's happening behind the scene. So let me go to my kubectl files, deployment hyphen rolling update.yaml. So I'm not going to make any change apart from my version. Let me go to this container registry path and my application repository. Let me go here and replace it with my new version V2. Let me save it. Okay. And let me do a deployment again. Kubectl apply hyphen f deployment hyphen update.yaml. Okay, if you have seen here, the service is unchanged, which means the same IP of my end URL access, but my deployment has been undergone switching. That is what it is now configured. So now let me see my pods to see that. If you see here, all my three pods are in a terminating state, but the other three pods in running state. So which means my version V2 is running ready. So which ideally means there is no downtime at all while deploying my other version of my Kubernetes, other version of my application in my Kubernetes cluster. See, get pods 44 seconds. So if you see here, gradually my first pod is deployed in 44 seconds. So which means this pod has been deployed first, okay, and then the other pod has been started terminating. So similarly, one by one in round robin fashions achieve with that there is no downtime provided for this deployment strategy. Thanks guys for watching the session. Next session I would be getting back with you the deployment strategy of a blue green deployment in another video session. Thanks for watching. Have a nice day. Bye bye.